Now, you'll remember it's been nearly 5 years since the Deepwater Horizon leaked 200 million gallons of crude oil into the Gulf of Mexico, and millions of gallons of that oil were never really accounted for. Now scientists say they've discovered as much as 10 million gallons of it in sediment on the ocean floor. So Dr. Jeff Chanton is a professor of oceanography at Florida State University, and he led this study, and he's going to join us live this morning to talk a little bit about it. All right, so Dr. Chanton, first of all, thank you for being with us this morning. And let me just ask you this. If everyone kind of gets that when you pour oil in water and you look at it, the oil stays on the top. So how do we find oil sediment at the bottom of water?
Well, it was a complex mechanism. The oil certainly did come to the surface. And there it was acted on by sunlight, which removed some of the more volatile or lighter components. And then the oil stimulated a response, the degraded oil. Once it was degraded, the oil stimulated a response from bacteria and phytoplankton that were in that upper water column. And it caused the production of this mucus, or sea slime, if you will. And that caused these bacteria and phytoplankton to kind of aggregate or clump together. And they formed these clumps, and then these clumps picked up clay particles, because you recall that this area is in the zone of the Mississippi River influence. So they picked up these clay particles, and then so that combination of events, the clumping, the aggregation, makes a particle larger, and that makes it more likely to sink faster. And then they picked up these clay particles, which serve as ballast and makes it sink. And so we think that the oil went to the surface and then had these processes act upon it, and that caused it to sink down to the seafloor.
All right, now that's the natural process. Now, I was one of the longest embedded reporters in that area during the spill, and I noticed that they were using, and we reported they were using, about 1.8 million gallons of a chemical dispersant that was known as Corexit. On top of this particular spill, their intent was to break up the oil. So now, do we know if that had any impact on how much oil got to the seafloor or the Gulf floor?
People are doing laboratory experiments right now with and without Corexit to look at this flocculation process and to determine the role that which Corexit had in causing this flocculation or accumulation to occur. And so right now it's not exactly clear the precise role of the dispersant. It was present at the time, and so it may have been important, but it's too early to say right now. We're doing a lot of lab work on that process.
All right, good, and I'm sure you'll let us know when you know more. Now, let's talk about the impact on sea life. What is the long-term impact to have oil sitting on the ocean floor or the Gulf floor? There's always some kind of natural oil that's seeping through there.
Yes, there is a lot of natural oil seepage in the Gulf of Mexico. And that was a good thing in the long run, because there were microbial life forms that could eat the oil once it was released from the oil spill. However, my work and the work of our team here indicates that there is a layering of oil over normal sediments, and that this layer was about 1 centimeter thick. Now, over time, this will become buried. And, you know, a lot of scientists, when the oil is removed from the water column, they think, oh, that's great, because, you know, that cleanses the water column and gets it out and removes it to the sediments. But the water column has actually more oxygen in it. And so when you transfer the oil to the sediments, that's more of a hypoxic or lowered oxygen concentration region. And so that has a tendency to preserve the oil. So if you're going to leave the oil in the system, it's going to be in the sediments. And there are life forms that live in the seafloor, for example, burrowing worms, and these worms swim through the sediments and they ingest the oil. And so they would be exposed to contaminants that are within the oil. And then if they're eaten by other fish, there is a possibility that this contamination could reside in the deep food chain, you know, for an unknown period of time, which, of course, we're researching now.
It's a delicate balance, sir, and we were talking about it the entire time we were there. The oxygen levels in the water, the dead zones that already exist due to that, and are we changing that now? So you mentioned maybe some of that getting into the food chain. Do you believe that it will? And we've got 30 seconds, and then I want to tell you that BP has responded, so we're going to carry this through the break with their response. Okay. But do we get it into the food chain?
There is evidence that some of these contaminants are in the bile and the bile of fish. And so there does seem to be preliminary evidence that is getting into some fish.
All right. Now, so we did reach out, of course, to BP. We wanted to hear what they had to say about it. So right after this break, we're going to tell you their response, and then we're going to give everybody a chance to talk and understand, because there always are two folks or two sides to any kind of situation.